Hey guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have an amazing problem that we're gonna be talking about, guys. So I like it a lot. So let's go ahead and read the prompts today, guys. So before we do that, guys, I would appreciate you guys to go ahead and I would advise you guys to go ahead and subscribe and like this video, guys. And comment. I'm saying get the engagement going, guys. Show some support. I'm saying it really means a lot. So let's go ahead, guys. Right, so the problem's called clone graph, right? So it says given a reference of a node, right, in a connected undirected graph, it says return a deep copy of the graph, right? It says each node in the graph contains a value and a list of nodes, right, of its neighbors, right? So they show us exactly what's up, right? They show us the value, right, which is the value of the node, right, and then the neighbors, right, which is a list of nodes, right? So it's exactly what we have here, guys, right? Sorry. So, okay. So he says on test case, right? So for simplicity, each node's value is the same as the node's index, one index, right? For example, the first node with value equals 1, second value equals 2, and so on, right? So the graph is represented in test case using adjacency list, right? This is what we're pretty comfortable with anyway, right? You know what I'm saying we're pretty yeah. So he says an agency list is a collection of other. So we know all of that. We're not gonna worry about that. If you guys don't know what agency list is, right? It's just a way for us to represent graphs. So I'm saying I have a playlist on graphs, so check that out if you guys don't know what that means, guys. So it says the given node will always be the first. The given node will always be the first node with value equals 1, right? Cool. You must return the copy of the given node as a reference to the clone graph, right? So guys, pretty much what they're telling us right now, right, is that we're going to be given a graph, right? And our job, right, is to return a copy of that graph, guys, right? So they show us a couple of examples to make sure that we clearly understand what they're asking us to do, right? And I'm saying, so you see the original graph, right, consists of 1, 2, 3, 4, right? So it's a pretty good graph, right? And I'm saying, so we see that they're showing you that's not what they mean, right? You can't return the same graph, right? You know what I'm saying? Yeah, you can't take that easy way out, right? Just like we can't say the nodes were cloned, right? But the graph is messed up. So it needs to have the exact same connection, right? So you see this one is the exact same graph, right? We didn't make anything, right? We just get the node and then send the node back, right? We can't cheat it that way, guys. So they're asking us that this one, right? One, you see 1, 3, right? That's not a good connection, right? Because 1 is not connected to 3, even though it's a graph. I'm saying, but the connection needs to be the same as it was, as you see here, guys. So it needs to be a copy of it, and the connection needs to be in the right order, right? See this one, right, is a copy, right? I'm saying it looks exactly like it, but they're not the same nodes, guys, right? They look the same, but they're not the same node, right? They're not the same. They're not the same reference of the nodes, right? The values are the same, but the reference are different, right? And there are the clones of the respective nodes there, right? Which is pretty good. So this one is the clone of this one, two is clone of this two, right? So pretty much everything aligns well. We give them a clone graph, right? I'm saying that's what the question is called, clone graph. You know what I'm saying? So this is the clone version of this exact graph, right? Right. So yeah. So this is just showing us how they're gonna pretty much give us the input and what kind of this expected output that they need, right? So guys, so how can we solve this problem, right? So you could see the problem kind of gives us same vibe as the that problem that we did a while back, right? It's called maybe clone linked list with random pointers, something like that. Where it's kind of the same principle, guys, what I'm saying. So we just need to find a way to clone that graph and put it in this that order, guys. Pretty much kind of the same thing. So pretty much we're gonna pretty much use pretty much a map, right, to kind of keep track of the copies of the nodes, right? So we can make the connections as they are in the original graphs, right? So that's what the hash map really gives us constant time access to a copy of a node, so we can easily do the manipulation. It's not gonna hurt us in terms of time complexity, right? So this is what makes a hash map, guys, extremely good, extremely insane. You know what I'm saying, so I like it a lot. So the hash map, right? So it might be saying, okay, how's the hash map gonna help me make all the copies, right? So there's more stuff that I'm gonna tell you guys, right? So what we're gonna also need, guys, we're also gonna need to do some kind of traversal, right? Just like we traverse the linked list, right, to make the connection, right? We need to traverse the graph to make the connection, right? So we could do a depth first search, we could do a breadth first search, right? So up to you what kind of flavor, what kind of stuff you want to do, right? But we're gonna go with the breadth first search solution for this problem, right? It's extremely clean and you know what I'm saying, very classic, very, you know what I'm saying, like clean for interview settings. So this is exactly why we're gonna do this, guys, right? So I'm gonna walk you guys through the steps, right? So pretty much what we're gonna do a breadth first traversal, starting with the root node, a source node, right? That's the source node, right? So we start doing the breadth first search, guys. The breadth first search on one, right? So that we create a copy of one, and then we visit all of one's neighbors, right? So 4 and 2 are the neighbors. So we create a copy for 2, right? Because we want to make the connection, right? Because 1 now, it's gonna add 2 to its neighbors, right? So that's why we end up doing that, guys. It's very, very important, right? And then 4, it also needs a copy. So we create a copy for 4, and then we put 4 into the one's neighbors, right? The list of neighbors, because that's how every node keep tracks of their neighbors, guys. So this is where I'm doing that, right? This is the representation of the neighbors, guys, right? Very, very, very important, right? So we do that. After we do that, we add 2 and 4 to the queue, right? So that they can be processed as well, so that they process their own neighbors as well, right? So we know how our breadth first search works, guys. So if you guys know what I'm talking about, I have a playlist. Most likely gonna have that. So yeah, we have a playlist for you guys, to know how to do the breadth first search, right? So very, very important prerequisites, things that you guys need, right, to be able to solve this problem, right? So we're gonna do breadth first search. So as we're doing breadth first search, guys, we create the copies, we make the required connections, and just like that, at the end, after we end up doing all of that, right, we return on the root node, right? We return on that node that was given to us, right? We return that copy, right? So 1 will be the one that's given to us, right? So we return the one's copy, right? So one's copy is going to give them access, right, to pretty much the graph, the copy graph, right? The clone graph, guys, right? Which is an exact same thing as this one, but it's a clone version, right? They have their own, they have different references and all of that, right? So that's how we're gonna end up doing that, guys. So let's go ahead with the code implementation. Hopefully you guys will follow through and everything made sense, guys. So what we're gonna do, guys, we said that we're gonna have a I'm gonna do a depth first search, right? Q view linked list, right? So new linked list. After we do that, right, we're gonna pretty much add the node to the queue, guys, as the starting thing, right? So I told you guys we need a map, right? A map, guys, to pretty much keep track of the copy, guys, right? So that we could easily do the connections, which is very, very important, guys, right? So while the queue is not empty, right? So we're pretty comfortable writing BFS, right? We can do that in our sleep, right? So pretty much what we're gonna do, guys, we're gonna take out current node, right? The current node that we're on, so let's call it current node. So we take that out of the queue, right? So we're gonna do a check, guys, right? Which is important, right? So if the map, right, does not contain, right, does that contain that node, right? If it does not contain it yet, guys, what we're gonna do, we're gonna create a copy of that node, right? So first things, we add 1, right? We add 1 to the queue, and we check in the map, right, that we have, right? Do we have a copy for this node yet, right? Current node, right? Nope, we do not have a copy, guys. So because of that, we're gonna have to create that copy, which is important. We do current node, that val, right? That's how we get the value, guys, right? Create that val, so we create a copy for it, right? And after we create a copy, we're good, right? Okay, all right, so create a copy. And then after the copy, guys, we simply visit our neighbors, right? That's kind of the next logical step to for us to do, guys, right? So empty. So int neighbor. Right, so the neighbor, right? So what is it? Is it map that it will be, so neighbor will be on cur node. Where are the neighbors at? It's that neighbors, right? I'm assuming, right? That neighbor. So we are gonna visit all the neighbors, right? So yeah, it's not int. It's gotta be node, right? Because it's a type of the list of neighbors, right? All right, so we got that. So we gotta visit the neighbors. So we're gonna do, guys, we're gonna do a check, right? If because we're gonna be doing this step, right? So now we need to check, guys. Do we have a copy of the neighbor yet in our map, right? Because the map, guys, is what's helping us keeping track all of the copies, right? Which is very, very important, right? So all the copies exist. They exist, like, because we have reference to it in the map, right? So that's how we're gonna create the connection, guys, because we're gonna have a constant time access to the every node's copy, right? So we're gonna check, guys. Does the map, right? Does it contain that neighbor, right? If it does not contain that neighbor, guys, we're gonna end up creating it for, right? Map that put neighbor in a new node, right? Because we get copy, and it's gonna be neighbor that val, right? We add that copy to it, and yeah, so we're adding that neighbor to it, right? So hopefully that kind of makes sense. So we do cur node, right? So pretty much how it's gonna happen. So map that get, right? Get the current node, right? So this is not the copy, right? So we get the copy of that original node, right? Say 1, for example, right? So we get 1, right? 1, right? And then we're doing that, right? So we get that copy, and then we also, now we're gonna say, all right, that copy's neighbor, right? All right, the copy that its neighbor, right? Neighbors, right? That's keeping track. It's a list of neighbors. We're gonna add, guys, add the neighbors, right? It's real neighbors, right? But it's copy though, right? It's copy right there, guys, right? So map that get the neighbor's copy, right? Right, and then just like that, guys, this step, right? It's very important. So now we're able to create the connection, right? So pretty much what's happening here, guys, which is important. So we 1, right? So this line we put 1, right? So 1 is here. We take 1 out, right? The original 1, right? Which is important, right? And then we check, does it have a copy, right? If it does not have a copy, right? Which is important. It does not have a copy. Then we create a copy for it, right? And then now, after you do that, guys, we visit all of the original graph, right? All of its neighbor, right? So we're gonna visit 2 and 4, right? So we visit 2. We check, is 2 in there yet? No, it's not in there yet. So we create a map. We create a copy for it, right? It's exactly what we do in this line, right? And then, guys, not now. And then, guys, after we do that, guys, we have to create that connection, right? 1 and 2, because we just created a copy for 2, right? But they're not connected. 1 and 2 are not connected yet, right? So that's why we need to add this line, guys, which pretty much creates the connection 1 to 2, right? So we get map that get cur's node, right? Which is the copy of that node, right? Get a copy of get that node's copy, right? Get my neighbors and add that the neighbor, but the copy one, get the neighbor's copy and add it to it, right? So this is exactly what's going on here, guys. So kind of a little bit confusing, right? So pretty much all one of the things that we need to also do, guys, make sure that we add that neighbor, right? So pretty much if a copy of that neighbor does not exist yet in the map, right? That pretty much tells us that we haven't visited that neighbor yet, right? So because of that, we add it to the queue so that it itself can be processed, so it can visit all of its neighbors and do the required connections, guys. So very, very important, guys, that you guys understand what I'm doing here. So after that, guys, we simply do a map that get get the node, right? Get the node that's given to us, right? Passed in. Yeah, and then once we do that, right, pretty much they'll get a reference to one, right? And then one is gonna pretty much give them access to the rest of the graph, guys. So just as simple as that, right? So to recap, right, pretty much we add the node to the queue. We process the nodes one by one, right? We check if a node, right, does it exist? Does a copy of the node exist yet, right? If it does not exist yet, right, we create one for it, right? And then we visit all the neighbors, right? And then we do the connection, right? So if the neighbor does not exist yet in the map, right? Which means there's no copy, then we add it to the queue so that it can be processed as well, so it can visit all of its neighbors. And then we also create a copy for that neighbor, right, in the map, right? And then after we end up creating a copy of that neighbor in the map, right, we can easily do the connection, right, as we go, right? So that's why we do get that current node, get that current node's copy, right, from the map, get the neighbors, right, and then add that neighbor, that copy of the neighbor that we're on right now, right? And just like that, guys, we did a connection and we're Gucci. We're in good shape, right? So it looks like everything's correct. Let's press submit. See if we pass all the test cases. Pretty much, let me see. I think we're forgetting a edge case, right? So if node is equal to null, right? Return, guys. Well, all right. So we return node, right? Press submit. Awesome, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time to watch this video, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next one.